Hi, my name is Vivian Molloy, and this summer I worked in the Gore Lab with my mentor, Harel Bakker. And my research aimed to contribute to making maize more drought tolerant by increasing the water use efficiency. And we did this by investigating how the SLAC1 gene, which is a gene that regulates stomatal closure timing in maize, affected stomatal density, pore width, length, and area for 16 different SLAC1 hybrids from 8 different genetic backgrounds. And we hypothesized that SLAC1 will not have a significant effect on stomatal density, but it will have a significant effect on the pore width, length, and area. So the main goal of this eventually is to be able to control the SLAC1 gene to the times of day when water use efficiency is most optimized, morning and evening. These are when the ideal climate conditions are for water use efficiency. We phenotyped in 2 different vegetative stages, V6 and V9, across 6 time points each day from 8 a.m. to 8 p.m., and we collected stomatal imprints. We first found that SLAC1 does not significantly affect stomatal density for each vegetative stage. So on the y-axis, we have stomatal density. On the x-axis, we have each of the 8 genetic backgrounds, and we're comparing between the wild type, which is blue, and the mutant, which is red. So no significance there. However, there was significance between vegetative stages, and this is most likely due to just difference in phenological stage. We also found that SLAC1 does affect pore area for 3 different genetic backgrounds. On the x-axis of each plot is each of the 6 time points, and on the y-axis is pore area. And each plot represents its own genetic background. So you can see for these 3, there is significance between alleles for certain time points. We also found that SLAC1 does affect pore width for several genetic backgrounds. The same layout here as pore area, except there's pore width on the y-axis. And you can see that a lot of the significant p-values are occurring at the last time point. This is 6 to 8 p.m., and this is when water use efficiency is most optimized. We also wanted to model our 3 traits with stomatal conductance just for the V9 stage. We found that pore area had the highest correlation with stomatal conductance just for that stage. And these are the 4 genetic backgrounds that we chose to make a Gaussian curve fitting. So you can see that there is some variation between backgrounds and between hybrids here, but overall we could not extract parameters from this fitting because we had too much noise in our parameter measurements. So.
Okay. You did a fabulous job. I'm just wondering, are any of these results not what you expected going into the project?
Honestly, I did not expect us to have as many significant p-values when comparing between alleles for pore width. I actually expected more significant between alleles for pore area because I would think that would be more accurate. Also, pore area had a stronger correlation with stomatal conductance. So it was definitely interesting that pore width showed a lot more variation in significance and also variation between time points.
Well, you did a great job. Thank you very much.
You.